12(1). Two objectives with 12(1). We're going to identify the nth terms of an arithmetic sequence, and we're also going to be able to look at the sums of an arithmetic sequence and call those a series and find the sum of series. And we're going to look at two equations for both of those. So let's just do a brief introduction to an arithmetic sequence. When you take a look at these first three terms in a sequence, it's pretty straightforward to figure out what the next couple terms are, just based on the pattern that you recognize here. So one thing that we do notice about these is that each single one of these terms is the same distance from the previous one. That distance is 3. It's going up by 3 each time. And that at its core is what an arithmetic sequence is all about. With an arithmetic sequence, we have each term having the same common difference from the preceding term. So one thing to notice here is that with this formula here, you have your first term. This right here could be defined as a second term. This right here can be defined as a third term, and so on and so forth. So notice something here, that difference that you're adding here turns out to be one less than the numbered term. First term, second term, third term. Notice that third term there's a 2 there, the second term there's a 1 right there. So let's use this knowledge to do a couple things here when it comes to working with the sequence. First thing you should do with the sequence is find the common difference. The next move you should make is add the common difference to the previous term to generate the next term. So if we take a look at a sequence such as this one here, first job here is to find the common difference. Notice that each term is 4 more than the next one. So once we've nailed down that the common difference here is 4, we can use that now to fill in the 10th term. The 10th term could best be described using this type of expression here. And notice what we're doing here is we're kind of taking advantage of this knowledge right up here. The first term, the second term, the third term. So in other words, the 10th term would be that same first term, a sub 1, plus now 1 less. If we're doing 10 here, we can call that 9 right there. And then we can multiply that by the common difference there of 4, and we arrive at 27 here for the 10th term. What about that 131st term? When we get some ridiculously larger numbers like this, it really becomes important for us to rely on the formula. So if we do that to find the 131st term, notice that we can still start with the first term of -9, and then we're adding 4 130 times to get to the 131st term, which arrives us at our answer here of 511. So that's a basic gist on how to deal with an arithmetic sequence and how to generate and find other terms. Let's look at the general form for an arithmetic sequence. So if you're ever being asked to find the nth term, whether it's the 5th term, the 27th term, the 1000th term of a sequence, to find that term we take the first term and we add this many of those common differences there. When we were talking about this many, it's the difference between whatever term this one was that you're trying to find, whether it's 27th term and then the first term here, and that one could vary too. Let's see it working for us here with a couple of problems. So this particular example is asking us to figure out what the first term was, and all we have to work with here is that the 18th term is -45 and the 19th term is -17. To find that first term, recognize that we could use the 18th and the 19th term to figure out what the common difference is. Notice we have 28 there, the difference between those two. We went up 28. So now that we know that the distance, the common difference is 28, let's now use the formula. So the 18th term would be equal to the first term plus n minus 1 in this case, and I mentioned this in class. Try and pay attention to the fact that whatever numbers here and whatever numbers there, you're putting the same numbers here and there. So 18th term and first term, we're going to do 18 minus 1, and then we throw that common difference in there of 28. Next, we know that the 18th term is -45, so I'm substituting that in there. Simplifying the business that we have over here, 18 minus 1, that's 17. 17 times 28 gives us 476. So now this just becomes a simple algebra problem of now subtracting 476 from both sides. Let's compute that answer. So now we have negative 521 for the first term. Let's look at the next example. This time they want us to find the 23rd term, and we're only given that the 30th term is 72 and the 41st term was 215. What I was saying before is that you don't necessarily need the first term to use that formula. Take a look at this. Let's find the common difference by setting up the equation. The 41st term is equal to the 30th term plus 41 minus 30 times that common difference there. Now let's substitute the two values in here of 215 and 72. And now we have an algebra problem that we can solve for D. So by subtracting the 72 and then dividing by 11, we arrive at an answer of 13 for our common difference. Now we can reset the formula, start at the very beginning, and now let's throw the 23rd term in there, and then let's use either the 30th term or the 41st term, doesn't really matter. So using the 30th term here, we take the 23rd term and add the difference there of 13. We add that, let's see here, it would be 7 times. We do 30 minus 23. Let's substitute the 72 in there, and doing the math there, 7 times 13, we get 91. So all we need to do now is just subtract 91. We got it there, negative 19. Great. There may be a problem down the road where they might ask you to fill in the missing terms. So suppose the first term was 3 and the 7th term was 0. Can we still use the formula there? We sure can. What we call those numbers in between, we call those arithmetic means. So for this particular example, between 3 and 0, there's 1, 2, 3, 4, 5 arithmetic means, 5 spaces there. So there's one approach you can do here is, let's take a look at this. I need to go from 3 to 0. And how many times do I need to add D to do that? Can we count those up? 1, 2, 3, 4, 5, and 6. 6 differences. So in other words, 3 plus 6 of those D's will land us right at 0. So now we can just solve this algebra problem for D. So subtract the 3 and then divide by 6, and we end up with negative 1/2. Now with those negative 1/2 put in play, now we can just plug in those choices there, subtracting negative 1/2 along the way. To arrive at our final value here, just doing one last check, subtracting 1/2, we do land at 0. Realize that the formula could have been used here too. Here we can say just simply the 7th term would be equal to the first term plus 7 minus 1, because we have a 7 and a 1 right there, and then we're multiplying by D. Substituting the 7th term, which is 0, and substituting the first term, which is 3, we arrive here, which if you notice is the exact same position here that we were right there, just switched around the equal sign there. So notice we still would have arrived at negative 1/2 for our D. So there's 2 ways you can do it. So to sum up arithmetic sequences, their definition is a sequence whose successive terms differ by the same number of D, which we call the common difference. Some easy characteristics to recognize about arithmetic sequence is that they have a constant common difference D, and the terms in the sequence kind of behave like a linear function with rise over run, but your domain just gets restricted just to natural numbers. Some examples of this situation look something like this. Notice there's arithmetic sequences where we can be increasing, there's some where it's decreasing. But the common theme throughout all of them is that there's the same difference every single time. You are adding, 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 adding. So arithmetic sequences, it's all about addition. All about addition, all about addition. So the formula that you use most regularly with an arithmetic sequence is this right here. The general form. Take the first term, add D n minus 1 times. Now the arithmetic series is just the indicated sum of the terms of a sequence. So given whatever sequence that you're working with, you can find a series by just adding up all those terms in the sequence. We use this symbol S of n, which indicates the nth partial sum. So you'd be looking for maybe the sum of 30 numbers, the sum of the first 30 terms. You'd be looking for the 30th partial sum, S of 30. We have a formula for this. To find the sum of the first n terms of a series, what we need to do is take the, notice how many terms that we're adding up, divide it by 2, and then what we see here in the parentheses, to put it as simply as we can, is to take the first term in the sequence and add it to the last term of the sequence. So let's try it on a problem. So looking at this example here, find the sum of the first 60 terms in the series. Note that 9 is the first term in the series, 304 is the 60th term in the series. So we're all set up for good things here. Let's just run through this formula here. So we're trying to find the sum of the first 60 terms. So we'll write down S of 60 here. Now we need to take n divided by 2. In this case, n was 60, so we're going to do 60 divided by 2. And now we need to multiply that by the first term times the last term, plus the last term. So 3 plus 304. Let's simplify this. So we have 30 times times 313, giving us a final answer here of 9,390. Pretty straightforward. Pretty easy when they give you the first and the last term. But what if we didn't know the last term? Take a look at this example. So notice this one, we were trying to find the sum of the first 35 terms. We're given the first term, which is 7, but we weren't given the 35th term. So what do we need to do? We're going to find the 35th term using the nth term formula from earlier in this video. So there we go, 35th term. We take the first term and add 35 minus 1, times it by that common difference. Now, do you see where we got the 2 from? Sometimes they won't tell you what that common difference is. Sometimes you're going to have to look right here and right there and notice, hey, you're going up 2 each time. So now substituting our values in here, the first term was 7. Doing the math there, 35 minus 1, so 34 times 2 gives us 68, which means that our last term, our 35th term, would be 75. Alright, so now we can use the sum formula again. So the sum of the first 35 terms, 35 divided by 2, and then the first term 7 plus the last term 75. There we go, 1,435. So to sum up, good one, Mr. Cook. To sum up arithmetic series, let's first look at the definition, which quite simply put is just the sum of the terms in an arithmetic sequence. Some characteristics. Only really one stands out here, is that you can use it to calculate partial sums. Some examples. Notice all those plus signs and minus signs. You're adding or subtracting all of your terms together. And the big time formula you're using here with series. To find that sum of how many terms you need, take those terms, divide it by 2, and then add the first term and the last term, get that sum, and then you multiply them times n over 2. Okay, so that's 12.1.